problem to be continued, and today we discuss about the power of the lens also. Then after the power of the lens, we discuss about next topic, reflection of light. Now one more problem will be there on this. So before that, first we discuss about the power of the lens. Power of the lens. It is denoted by the letter P. Power of the lens is denoted by the letter P. Power of the lens means it is the power of the lens is the reciprocal of the focal length. Reciprocal of the focal length means focal length is F. Focal length is said to be F. So focal length is F. Then power of the lens. Power of the lens is equal to P. P is equal to 1 by F. Reciprocal. 1 by F to consider in meter. 1 by F meter we have to consider. So suppose this meter to be taken in centimeter, what happens? To be take this value into centimeter, what you get? P is equal to 1 by F by 100. F by 100 centimeter. This value to be considered in centimeter. 1 by F by 100 centimeter. This 100 goes up, then P is equal to 100 by F. And this value will be in centimeters. Suppose direct meter will be there. This value to consider 1 by F to be considered. That's the power of the lens. Reciprocal of the focal length is called as the power of the lens. Suppose we know the focal length, we can calculate its power. Suppose power we know, we can calculate the focal length of the lens also. Now, how to find that? F is equal to reverse. F is equal to 1 by P. F is equal to 1 by P we have to use. Okay. And the unit of this power of lens is diopter. Diopter is the unit of power of the lens. So simply represented D also. So D stands for diopter. So diopter means power of the lens unit. Power of the lens unit. So power of the lens is measured in diopters. Power of the lens is measured in diopter D. Okay. So on this base we can do one of the application or one of the problem on the base of this power of the lens. Now, in this to be considered, to take one of the question, so by basing the problem. So by basing this, one of the problem we have to do. So on this we can consider a convex lens forms a real and inverted image of a convex lens. A convex lens forms a real and inverted image of a needle at a distance of 50 centimeters. At a distance of 50 centimeters from it. So 50 centimeters from it. Now, where is the needle placed? Where is the needle placed? Where is the needle placed when needle placed in front of the convex lens? In front of the convex lens. In front of the convex lens. If the image is equal to the, if the image is equal to the size of the object, if the image is equal to the size of the object, size of the object, and also find the power of the lens, size of the object, and also find the power of the lens. Power of the lens also to be calculated here. Now, in this case, what happens? The size of the image is equal to the object size, means the object is placed at the center of curvature. At this condition only, size of the image and object size will be equal. That's why the image is placed at where? 2f, or at center of curvature. So the position of the image should be at 2f, since the image is the real and same size. So to conclude the answer, the position of the image should be, the position of the image should be, the position of the image should be at 2f, or at the center of curvature. At 2f means center of curvature. Center of curvature of other side. Center of curvature. Since the image is the, since the image is the real and same size, since the image is real and same size of the object, or same size. So in this, what is the object distance will be given? Object distance will be given as 50 centimeters, means object distance u is equal to, so in convex lens u becomes minus value, remember that, 50 centimeters, and v is also same, 50 centimeters, same size, same distance we have to consider. Now we have to calculate the first focal length of the lens, f is equal to how much? So you can recall the formula, 1 by f is equal to 1 by v minus 1 by v, that is equal to 1 by 50 minus of 1 by 50, that is equal to 1 by 50 plus 1 by 50. Yes. Now LCM should be 50. So in this LCM to be taken 50. So that is equal to, LCM is 50. 1 plus 1. 1 plus 1 means 2. 2 by 50. So we get 2 by 50. So 2 by 50 means 2 ones are 225 are. That means 1 by f is equal to 1 by 25. That is f is equal to 25 centimeters. F is equal to 25 centimeters. Focal length we get. Now power of the lens. Power of the lens P is equal to how much? So P is equal to 1 by or 100 by f, right, in centimeters, 100 by f centimeters to be considered. So that is equal to 100 by 25. 100 by 25. So 25 ones are 24 fours are. Therefore P is equal to 4D. D means diopter. D stands for here diopter. So 4 diopters is the answer. Okay. So power of the lens must be 4 diopters. Okay. Next understand this problem. So here object distance and image distance will be same. How can you say that size of the object image is equal to the size of the object? Means both will be same. Due to that we have to conclude at this point, right? Now another one to be considered. Another question. Question number 2. In this, find the power of the concave lens of focal length 2 meters. Find the power of concave lens. Find the power of concave lens of focal length 2 meters. So here focal length is given as 2 meters. Then we can calculate the power of the lens. So here for concave lens, focal length must be negative. Focal length should be taken as negative. So focal length of the lens, focal length of concave lens, f is equal to minus 2 meters, or otherwise 2 by 100 centimeters also to be right, or otherwise 2 meters to be considered. Now power of the lens, P is equal to how much? So P is equal to 1 by of meters. Meter is the unit. Now that is equal to 1 by minus 2, that is equal to minus 0.5 diopter. Minus 0.5 diopters. Let's say concave lens we get the negative value. For the convex lenses we get positive values. Remember that. So for concave lens it is the negative value. Remember that for concave, because in next chapter human eye. So in this also we can discuss about this lenses. So eye defects will be there. For that eye defects we can use this lenses. So that's why there also these are very important. For convex the value is positive. For concave the value will be taken as negative. Remember that. So concave and convex differences to be observed. And next one to be observed. Next problem to see. Length of the lens is over. So the diagram is also completed. Position and convex mirror. So mirrors means we discuss in Now another one to be considered. Find the focal length to head calculated. Find the focal length of the lens. Find the focal length of the lens. Focal length of the lens. If power of lens is, find the focal length of the lens of power minus 2 diopters. Minus 2 diopters. What type of lens is this? So what type of lens is this? So minus will be there. You know that if minus value will be there, what is the lens? Its lens will be the what kind of lens? Negative value will be there, means it is a concave lens. So first we have to calculate focal length of the lens. So focal length f is equal to 1 by p, that is equal to 1 by minus 2, that is equal to minus 0.5 meters, or otherwise minus 50 centimeters. In centimeters to consider, this value becomes 50. Yes, 100 by 2. 100 by 2 means 50 centimeters, right? So power of the lens P is equal to minus, not power, focal length. Focal length F is equal to 0.5 meters, or otherwise sometimes it is given 50 centimeters. Now what is the nature of the lens? So it is concave lens. It is concave lens. Why? Because its power value will be given as negative sign. Next, another one to be considered in the same manner. Here, a doctor prescribed, that means in eye defects problem it will be get. So before that only, earlier it will be there, we can discuss about this. So what is this? A doctor has prescribed, a doctor has prescribed, a doctor has prescribed a corrosive lens of power, prescribed a corrosive lens of power, corrosive lens of power, corrosive lens of power plus 1.5D, plus 1.5 diopter. D means diopter. Find the focal length of the lens. Find the focal length of the lens. Focal length of the lens. Find the focal length of the lens, and if the lens is converged or diverged also to be calculated. Is the prescribed lens diverging or converging? So in the question also will be given, is the prescribed lenses diverging or converging? Diverging or converging. So first of all, we have to calculate the power of the lens will be given. We can calculate focal length of the lens. So focal length of the lens means F is equal to 1 by P. You have to calculate here. So power of the lens will be solution. Power of the lens. Power of the lens P will be given as plus 1.5 diopter. Plus 1.5 diopter. Now focal length of the lens. Focal length of the lens. F is equal to how much? So F is equal to 1 by P. That is equal to 1 by 1.5. So to remove the 1.5, 15 by 10, that is equal to 10 by 15, right? 5 2s are 5 3s. So 2 by 3. 2 by 3. So 2 by 3 means to divide 2 with 3. 0.036 is 18. 2 already 0 is there. 2 6 is 18. Now what do you get? Focal length of the lens will be 0.66 meters or 66 centimeters. 66 centimeters or 0.66 meters. Now, this lens is a positive focal length. That's why it is the convex lens. So the lens is positive focal length. Therefore, it is the convex lens. Right? So convex lens has positive focal length. Therefore, it is a converging lens. So the lens is converging lens. Converging lens, that is convex lens. What is the lens we called as a convex lens? You have to say. Okay. So in this model you have to do, but another will be there in human eye. Next topic will be human eye will be given. So in that we can discuss some more examples of this power of the lens. Now we discuss about the reflection. So next topic we discuss here reflection of light. So reflection of light at different surfaces.